our guests. We are the Royal Astronomical Society of Canada, Mississauga Centre. So our meetings are sometimes here, a few other places, but we have a couple meetings every month. One is like tonight where we have one speaker, and then we also have other meetings where we have several short talks by members. I'm sure we'll have a talk soon with a lot of comet pictures. We've had a lot of talks this year of northern light pictures and eclipse pictures. So it's been a great year for observing stuff. Our speaker tonight is Dan Falk. And I've known Dan for how long? We've known each other
a lot since 91 eclipse, at least.
91 eclipse, yes. Oh my God. Okay. So I've known Dan since we were both little kids. And that's right. He wrote an article for the Globe and Mail.
And I got your career wrong. I think I misstated what you do for a living. So sorry about
that. But
I spelled your name right though.
But a fellow who was producing a movie about eclipses, Jeremy Podeswa, who ultimately became a director for Game of Thrones and stuff, saw it. And it's a long story. Anyway, so Dan has seen several solar eclipses. He is a science journalist and author, and obviously particular interest in astronomy and physics. Let me just go through this bio here because I don't want to get it wrong. His freelance writing credits include Smithsonian, Scientific American, New Scientist, Discover, Undark, Nautilus, Quanta, and many other publications, including Globe and Mail. So you see his name from time to time in various magazines and newspapers. He is the author of 3 popular science books, The Science of Shakespeare, In Search of Time, and Universe on a T-shirt. And he's also worked extensively in radio, co-hosts a podcast called Book Lab, which reviews popular science books as well. It's good to note that he's been recognized with an asteroid. Asteroid 20039 is asteroid Dan Falk. So again, this is not his first time here. I think he was mentioning this is 3rd or 4th or 5th time that he's given a talk to this group, which is great. We always like to have him back. His talk tonight, and I saw the article in Astronomy magazine, and I went, oh my gosh, because I'm really fascinated with Edmond Halley. And so when I saw that article, I thought Dan has to come and give us a talk about this, about Edmond Halley. Essentially, we all know Halley, and we please pronounce it Halley, not Haley. Halley's Comet has become so well known that it overshadows the English astronomer's other work, but Edmond Halley made important contributions to many branches of science. He worked out the size and shape of the Earth, as well as the size of the solar system. He mapped the Earth's magnetic field and studied the tides and monsoons. He tried to solve the problem of measuring longitude at sea. He predicted eclipses, and he was no couch potato. He sailed to St. Helena, a remote island in the South Atlantic, to chart southern stars. And on a recent visit to England, Dan Falk walked in Halley's footsteps in an effort to learn more about his life and legacy. So I'm looking very much forward to this talk. Please welcome our speaker, Dan Falk. Don't say Haley, don't say Haley.
All right, so folks can hear me, correct? Okay, good, awesome. Well, I'm delighted to be back here. Yeah, we've sort of lost track how many times I've spoken to this group, but it's a bunch. Raise your hand if you've already seen me speak here in this or the next auditorium too. Okay, a significant number have already seen me sort of do my thing. Let me see. So the last talk I gave, and it was next door in the other room, it was in 2019, and I believe it was on time travel. I think my title was Time Travel in Fact and Fiction or something like that. There is one small tragic element to that, which is that the hard drive that I had all my slides on for that talk crashed, and I'm left with just a shorter version of the talk that I had given earlier at Nerd Night. I mention this because in the unlikely event that you were there with your little audio recorder or video camera and you taped the whole thing, come and talk to me later. But on the other hand, it's not something I really need unless anybody invites me to give that talk again, which has not happened to this point. But if somebody does invite me to give that talk, I'll wish I had those slides. All right, so let's dig in here. I will be looking down from time to time just because I didn't memorize all my my notes, but um, oh yeah. So Halley, as Randy mentioned in the intro, you know, obviously from his comet, and if you're of a certain age, you will remember the winter of 1985/86. So I was a teenager or whatever, and I was living in Halifax, Nova Scotia, and we did get to see it. Not, you know, the view wasn't great, and it was a little fainter than everybody thought it would be, but it was very memorable. And then I guess it was February or March of '86. I was in Florida with my parents, and we had a slightly better view, which is to say, I think it was sort of the same view, but it was warm enough that you could actually be outside for a few minutes, because December was just more challenging. But at any rate, these are things that you don't forget. So I know if some of you saw Halley's Comet, I'm sure you do remember that happening. Let's see. So yeah, earlier this year, except my notes are out of date because I gave this talk at the Toronto RASC. So this should say a year ago, in 2023, I walked in Halley's footsteps in an effort to learn more about his life and legacy. Now, in fact, I didn't go to St. Helena in the South Atlantic, although that would be nice, probably. I just went to, oh, okay, I'm gonna just show these pictures of the comet. Sorry about that. This is I promised to come back right imminently to the subject of Edmond Halley, but I wanted to show off the pictures that I took last night from Keswick, north of Toronto. And yeah, I mean, it is what it is. We can debate later whether it was as good as or better than Comet Neowise or not quite as good. I think we can probably agree it was not as has not been as good as Hale-Bopp back in the spring of 1997. Anyway, we'll chat later about comets, perhaps. But I just wanted to show off those two quickie images. Okay, back to the title slide. Here we are. And as I say, I went to walk in his footsteps, which really just means London, and you can see Oxford in the upper left there. Those are basically my my destinations. I love doing this kind of thing, and it's kind of a privilege as a science writer to, I mean, not that anybody really reimburses me for my travels. It would be nice if they did, but at least, you know, I get something out of it, and I have a reason to be in these places beyond just being a tourist, which is very nice. And over the years, in particular for Astronomy Magazine, gosh, I've done Thomas Harriot, and I'm trying to remember. I did Newton, but it wasn't for them. It was for a different magazine. And Tycho Brahe a few years ago. So I mean, I've done this a few times, and I really enjoy doing this sort of thing. If you guys can think of like dead astronomers that I haven't written about for Astronomy Magazine, talk to me later, because maybe I've overlooked someone. I'll leave it here for a second. So Halley was born in 1656 in a place called Haggerston, now which still exists, except now it's just a neighborhood within London. So it was at that time a village, just a little bit northeast of the old city of London. I started my walkabout at the Royal Society, which you can see here in the middle. Well, it's a little hard to see the green dot, but at any rate, very centrally located, not far from Parliament, not far from Trafalgar Square, not far from Piccadilly Circus. Very interesting place to visit. The Royal Society, I know some of you know this, but the Royal Society is one of the world's oldest scientific societies, founded in 1660 when King Charles II granted a royal charter to it. And Halley would later be a fellow of the society and eventually take on the role of secretary. And this was my first time being inside the place, and it is a cool place to visit. You recognize Stephen Hawking, obviously, and the person on the right is biochemist Jean Thomas. So there are 5 known portraits of Halley. I mean, it's kind of interesting, right? I mean, today everybody takes a photograph of everybody else all the time. But in those days, you had to get someone to paint your portrait, and it took a while, and you had to have money. So there only are 5 known paintings. This is one of them, and it's displayed prominently on a wall, sort of in the grand stairwell of the Royal Society. And I call this one Old Halley because he's kind of old in it. He's in his 70s at this time, but they do have another one which they keep in storage, and I call it Young Halley. So I waited while this Royal Society person who was helping me out that day went into the back and took 10 minutes or so, and he came back later wearing white gloves, of course, and he fetched young Halley from the storage room. And here's the, I mean, you can Google it, of course, so that's what it looks like from Google image search, but it's the same picture. And of course, there are a lot of differences here. I mean, aside from just chronological age, in this one you see his real hair as opposed to a wig. And we don't know a lot about his personal life, but we have some details. He was the son of a wealthy soap maker. As a youngster, he took a keen interest in math and astronomy. In 1673, he enrolled at Queen's College, Queen's College, Oxford, my mistake. And he would return later in 1704 as Savilian Professor of Geometry. Oxford is, I mean, some of you perhaps have been, it's a great place to visit, so much to see, so much history. I mean, I feel smart just walking around the streets in Oxford. Yeah, Logic Lane, that we should have more places like that. I love that sort of thing. Yeah. Okay, Queen's College. The pictures you see there are a little more modern. They're not as old as the founding of the college, but nonetheless, a very cool place. So when Halley was a student, he probably lived in the college itself, and later when he came back as a professor, he lived here at number 7 New College Lane. I was very lucky with the weather. So yeah, this was 2023, and it was late April or early May, and just got quite lucky. It was a beautiful day in Oxford, and I sat down with one of the historians there and interviewed him at some length, and then just walked around and took photos. The rectangular structure on the roof is believed to have served as Halley's observatory. Now, honestly, I don't really know how much the buildings have changed since Halley's time, but from reading up and figuring out as best I could, they do think that is where he conducted some of his observations. It's not open to the public, but it's nonetheless very cool to see it. Let's see here. So, as I say, when he was young, he was very interested in math and astronomy. When he was still an undergraduate, he published papers on the solar system and sunspots. He wrote to John Flamsteed, who was England's astronomer royal, to alert him to mistakes he had found in published tables of the positions of Jupiter and Saturn. Pretty cool. And also mistakes that he noticed in the star positions published by Tycho Brahe. Now, Tycho Brahe lived, I mean, that would have been 75 years earlier, but Tycho's star tables were so good that they were still in use many years later. As I say, there are a lot of gaps in our knowledge of his personal life, but he did marry a woman named Mary Tooke, or Tooke, T-O-O-K-E, in 1682, and they had 2 daughters, and the marriage lasted 54 years until Mary's death. we don't have a portrait of her. It's just hard to say too much about her beyond what I've just said, unfortunately, or the daughters for that matter. Now, he was not a couch potato. He did get around. Oops, okay, there's the close-up of the little plaque at the house where he lived in Oxford. Right, okay. So there's a picture of St. Helena, which would be his ultimate destination on this trip to map the southern stars. Again, I've never been there, but from reading about it, and we also have Halley's detailed observation logs and that sort of thing, it's a terrible place to do astronomy. It really is. The weather was dismal. He tried to observe both a solar eclipse and lunar eclipse and was plagued on both occasions by clouds and by wind. He did eventually see a transit of Mercury from down there in October of 1677, and he did eventually succeed in charting the southern sky. Yeah, here are some of his charts. The one on the right is interesting. It's from a bit later, and my understanding, I hope I've got this right, but later in life, he did this voyage sort of closer to home around the English Channel and mapping the French coastline and stuff. I mean, here you see Ireland, England, and France. And part of that was because England and France were like perpetually going to war against one another. So knowing the exact location of all the French harbors was of vital, military strategic importance. So he didn't publish about that because that was just like, it was a secret. He would just probably gave his reports back to the Admiralty, and that was the end of it. Let me see here. But yes, let me go to the next one. Okay, isogonic lines. I hope I'm pronouncing it right. I won't try to go into too much detail here, but if you've ever played with a magnetic compass, you know that it doesn't point to the geographic north, or at least it doesn't. I suppose it could. It could happen to, but in general, the magnetic North Pole and geographic north are distinct from one another, and the angular separation between the two can be substantial, and often is. And it changes depending on where you are in the world. So this is a thing that had to be mapped, and Halley took a deep interest in doing that. Let's see here. Maybe the next one is the. Oh, okay. This is his route on a voyage that I haven't mentioned yet, but this is not the voyage to St. Helena. Oh, okay. It shows St. Helena, but he goes even further south, which I will say something about. Yes. So a few months after his return from St. Helena, he was on the high seas once again on a ship called the Paramore, sailing the Atlantic's southern reaches. And at one point, his crew spied 3 unusually flat, treeless, quote, islands that were, quote, covered with snow, milk white, with perpendicular cliffs all around them, close quote. Well, of course, these were icebergs. And the ship came dangerously close to being trapped in ice, but luckily the Paramore was able to escape northward. Let's see if I've got, okay, that's the catalog of the Southern Skies, or things are just slightly out of order. And, oh, okay, commemorative stamps from St. Helena. That's pretty cool. If I was a stamp collector, I would definitely try to get these. Right, okay. Let's see. The Paramore was able to escape northward, eventually reaching the island of Tristan da Cunha, where Halley was able to, quote, recover the warm sun who we had not seen in a fortnight, close quote. And as I read these passages from Halley's logs, on the one hand, I mean, anything's better than being trapped in ice. So, you know, great. Here we are at Tristan da Cunha. But if you Google Tristan da Cunha, you will find it is the most isolated geographic point in the world. It's an island that's far from any other point of land in the South Atlantic. And I mean, people do live there. I don't know exactly what they do. I imagine that even if you're an Amazon Prime member, I bet you cannot get your packages overnight. I should Google that sometime. But anyway, it's just fascinating that you know Halley's logs are still with us, so we can read them and I guess thank our lucky stars that we're not. I mean, it would be fun to go down. I don't know. I'd love to see these places, but like for a day or two each, not for a prolonged visit necessarily. Okay, let's see. I think I've got the eclipse map. Yes, here we go. I love this image. So another of Halley's accomplishments, predicting eclipses, and this map is of the path of totality for the April 22nd, 1715 solar eclipse. This is a bit, you know, later in Halley's life, but it was published just a couple of weeks, I believe, ahead of the event. So he must have been scrambling to crunch the numbers, obviously doing all the calculations by hand, needless to say, and then rushing it to publication. And from what I've read, it's actually quite accurate. Like, I think the path of totality only deviates from the real path of totality, which of course now we can calculate, by a dozen or possibly a couple of dozen miles, but not more than that. So it's really quite a good map. At home, I've got this on a postcard from, I think maybe like the Science Museum or something in London, and it's just a lovely image. Let's see. Oh, and I wanted to draw your attention to, so there's some text at the bottom, which I've blown up here to make it a bit bigger, although it's still hard to read. But there's a bit that I love from it's from approximately here, and it's where he says, hereby they will see that there is nothing in it, meaning in the event, more than natural and no more than the necessary result of the motions of the sun and moon. In other words, it's not demons or spirits or weird, unexplainable things. It's just science. It's the solar system doing what it does. We can predict these things, and there's nothing to be afraid of. And you know, one of my books, my most recent book was called The Science of Shakespeare. And in Shakespeare's time, you know, people were very superstitious and believed in different kinds of magic, and a lot of, you know, comets and things you might see in the sky were very scary, and nobody knew, you know, everything was sort of an omen, and nothing was very well understood. Shakespeare died in 1616. This is 99 years later. Well, over that 99 years, everything changed. Halley's world, I mean, it's not exactly the modern world, but it's a lot closer than Shakespeare's was just a century previously. Let me see. All right, so then we have this kind of near mythological event. This is the meeting between Halley and Newton. And you know, if you do some Google image searching, I mean, this has been cartoon rendered many times over the years because people are just fascinated by this event. And of course, there is no actual, I mean, you know, there's no actual painting of it or anything, I mean, from the time, but just what we imagine the encounter looked like. So Halley and Newton were both interested in how the solar system works, how planets move, how comets move. So Halley goes up to meet with Newton, who has clearly been working on this stuff, and the topic of conversation turns to the shape of planetary orbits and what's the relationship between if you had if gravity worked as a 1/r² force, what would be the resulting shape of an orbit? And Newton says to Halley, "Oh yes, well I've already worked all this out. Yes, it would give you an ellipse." And Halley says, "You worked it all out? That's great. Hey, share it with me. Show me your calculations." And he's like rummaging through his stuff, and it's like, oops, he can't find it. But he swears he did it, and he probably did do it. But he's a professor who keeps losing everything in a messy place, and he can't find it. So he says to Halley, "Don't worry. It wasn't that hard. I'll just redo the calculations. And I'll give you a ringy dingy when I've done it, and we'll talk some more later. But just, give me some time, and I'll just redo the math." So Halley goes back to London. Newton's in Cambridge, and some time goes by. But thanks to Newton's putting some pressure on Newton, Newton does eventually publish his masterwork, the Principia, the big book that's kind of kickstarts modern physics. There's a lot, even if this was a different talk, I'd go on and on about the Principia itself. I've just been reading a very interesting book about Émilie du Châtelet. I hope I pronounced her name right. She lived just slightly later, but not much, and she was in France, of course, and was amongst the various people trying to interpret Newton's writings. There's some kind of funny things going on. As I know some of you know this, of course, but what exactly is gravity and how does it work? Because the prevailing idea in those days was that, if you want to pull a wagon, you've got to actually pull on it. You can't be 10 meters away and just hope the wagon moves. You have to get a horse and some ropes and stuff like that. This appeared to be well understood, right? Mechanistic forces, but the forces have to involve things touching other things. So the fact that the sun tugged on the planets over open space was a little peculiar, and some people thought it didn't make any sense. So people like Leibniz and Huygens and others, and even Voltaire, were sort of arguing about this. But I haven't got to the end of this book that I'm reading about Émile du Châtelet, so I can't tell you how it ends. But it is very interesting that, here I am saying that Newton founded modern physics, and he sort of did, but there were still plenty of things to argue about still for many decades following its publication. Right, okay, let's talk some more about comets. So, in the fall of 1682, Halley carried out a series of observations of the comet that would eventually come to bear his name. He concluded that the object he observed in November of that year was the same object that had been seen in 1531 and 1607. You can tell what happens next. He did a bit of math, concluded that the object is moving in an orbit with a period of roughly 75 years. I mean, a little bit more than that, but approximately 75 years. So Halley predicted that it would return in 1758, which it did. Now, Halley unfortunately died a few years before that, but still, I mean, I bet Halley's ghost was like really full of joy when the comet came back right on schedule. And similar to what I was saying before about the eclipse not being a magical thing, this fact that comets were very mysterious, basically, throughout the Middle Ages and through history up until that point. But with the predicted return of Halley's comet, and with its coming when the astronomers said it was going to come, it was yet another indication that nature could be understood, that not everything was scary and not everything was the whim of the gods, but some stuff could actually be understood through science with some help from mathematics. So yeah, anyway, so it's a fascinating sort of case study. Total side note, but I finally, and it was actually also in 2023, but I finally saw the Bayeux Tapestry with my own eyes in Bayeux in France. Very cool if you have a chance to go there. Short train ride, about an hour on the train outside of Paris. And it's in a darkened room because, you know, photons would damage it. So you have to squint and stuff. But I mean, you can perfectly well see it, and there's a little audio guide. Can't take pictures, right? If you could take pictures, I'd be showing you the picture that I took of the tapestry, but you're not allowed to take pictures. But at any rate, it looks like that. And if all the, yes, you know, it's 100 or 200 feet long, but that's my favorite part, the part where like, oh my God, it's a comet. And the Latin translates as, what is it? It's not they gawk at the comet, but it's like they're mesmerized by the comet. I've forgotten the exact words, but the marvel. It's they, well, according to the internet, it's they marvel at the comet. So, all right, good stuff. Although, you know, I've seen Halley's comet, and it didn't look like that. But I mean, well, yeah, it was not that spectacular. All right, let's see here. So Halley was named Astronomer Royal in 1720. Sure, here we go. Following the death of Flamsteed. Now, on arriving at the observatory, let's get us there. So here, a couple of things worth noticing here are the observatory itself, and then his burial place, which I'll get to in a few moments. But it's down here, yeah, just around here somewhere in Blackheath. It's a half-hour walk and a very pleasant walk. But I'm going to say a few words about stuff you can see at the observatory. Right. Okay. Following the death of Flamsteed. Now, on arriving at the observatory in Greenwich, he was in for a surprise because he found that it had been stripped of all its instruments by Flamsteed's wife, Margaret, who said that Flamsteed had paid for all the instruments himself, so they were his. And so she took them. But eventually, Halley persuaded the government to pay him extra money, £500 apparently, which is, I'm sure, a lot of money in those days, to acquire new equipment, which is what happened. Halley also noticed that the stone wall on which Flamsteed had mounted his mural arcs, this is a device for measuring the altitude of stars as they cross the local meridian. Let's see. Well, I'll leave it there for a moment. That the wall was kind of sinking into the ground. But this is also, this instrument was used to define the zero line of longitude, which of course, I mean, it's arbitrary, but you have to pick some spot and call it zero, and you can measure the longitude of everything else relative to that. But you want it to be stable. You don't want it to be sinking into the ground. So Halley erected a new, sturdier wall a short distance away on which he mounted his own 8-foot mural quadrant. Okay, that's the grave, but we'll come back to that, I guess. All right, here's the mural quadrant. Let's see here. But the funny thing is, if you go to visit the so-called transit room, what you find is that there are 3 prime meridians, which is 2 more than I would naively expect to find on visiting there. So there's, I mean, how many equators are there? I was hoping just the one. So there's Halley's, and then there's a new one established by his successor, James Bradley, about a dozen feet further east. And then still further east, there's a 3rd one set up by Sir George Airy, who would serve as the Astronomer Royal in the middle part of the 19th century. And it's that 3rd one, the Airy line, that would become the official prime meridian, which is to this day marked by a brass plaque that continues outside, and that's where all the tourists stand and take their selfies with 1 foot in each hemisphere, et cetera, et cetera. I'm telling you this because partly because, first of all, the fact that there's 3 prime meridians, or have been 3 prime meridians, kind of was something I didn't know till, even though I had visited the observatory previously, but I had just totally forgotten this factoid. But it also hammers home the point that you could have as many as you want. Like, you could just take any place and call it the prime meridian because it's just a matter of convention. There is nothing special about that spot other than just historical happenstance. You know, that's where it's where, yeah, Flamsteed set up the king gave him some money, set up an observatory, put a transit telescope, and so that became the prime meridian. But the French had their own for a long time. Surprise, it went through their royal observatory in the suburbs of Paris, and then much later they eventually caved in and said, yeah, we'll just use the British one. But it is completely arbitrary. And I was joking about the equator. The equator is defined as being 90 degrees from the poles, and the poles are defined by the Earth's rotation. So they're all, shall we say, fixed, more or less. But the prime meridian is forever the toughest guy says, this is it. This is the prime meridian. So, all right, let's see. Oh yeah, and then this is something that I can't go into a lot of detail on because I don't understand it, but modern GPS systems use yet another meridian. So there's another imaginary line about 300 feet further east, and that's called the International Reference Meridian, or IRM. And if any of you, not right this minute, but afterwards or whatever, if you want to like explain it to me or something, that's fine, because I don't quite understand why GPS needs yet another meridian. But I'm sure there's a perfectly good explanation. Halley held the position of Astronomer Royal until his death in 1742 at the age of 83. I think we have to back up one because I had yeah, that's the original gravestone, which has since been replaced. I'll show you the grave in just a moment. But this one, let's see, yeah. So the Latin text on the gravestone reads in part, beneath this gravestone, Edmond Halley, unquestionably the most eminent of the astronomers of his age, rests peacefully with his dearest wife, as he was a man so greatly cherished by his fellow citizens during his lifetime, so let a grateful prosperity venerate his memory. And let's go forward now again to, yeah, so the actual grave at St. Margaret's Lee in Blackheath. As I say, it's about a half-hour walk south of the observatory. Terribly worn. So the one that they've took away and preserved at Greenwich is sort of in better shape. This one is very badly weather-beaten. And let's see here. So in all, 5 members of Halley's family are buried in the grave, along with John Pond, who served as the Astronomer Royal from 1811 to 1835. Note that this is more than a century after Halley. So I think that's again, this is something I don't know the answer to, but this later Astronomer Royal, like, how did he get his bones into Halley's grave? Like, that can't be very straightforward. But, he must have, yeah, I don't know, but I guess he pulled it off. I mean, presumably he honored and venerated Halley and wanted to get in there. And it's indicated on the plaque there or the inscription on the gravestone when you read it. Let's see, and another view of, well, that's just facing towards the old part of the ruined church that used to exist there. The modern St. Margaret's is across the street. And this, again, you've got Halley's tomb just sort of in the center, but I put this one up because these, I don't know if they're rental units or condominiums, but whatever they are, they're like above Halley's grave. And I was busy taking photos, but the friend I was with just sort of pointed this out to me. And I was like, yeah, that's like the people who live there. And look, it's okay not to have ever heard of Halley. And I guess it's okay not to know that that your bedroom overlooks his tomb. Like, it's not the end of the world. But I wonder, do they know, right? And of course, I didn't ring the doorbell because that'd be super weird, right? Hello, I was just wondering, do you know that you live? Your bedroom looks right out over, or your dining room looks out over the second Astronomer Royal and the person whom Halley's Comet was named after. But obviously I didn't do that. But it would be kind of neat, and I don't know how much it costs to buy one of those units, although I know it would be a lot, even by Toronto standards. But if they were giving them away, it actually would be maybe kind of neat to live there. Yeah, well, it is a lovely cemetery. I mean, okay. And then, so that's where his mortal remains are, but there's a memorial plaque in Westminster Abbey. Let's see here, not far from the tombs of Newton, Darwin, and Stephen Hawking. Now, there's a lot of text here, and I don't know if you can read it or not, but I'll just whip through it really quickly. So it says, Edmond Halley, this memorial marks the comet's return in 1986, intercepted by the European spacecraft Giotto, built by British Aerospace. And then there's a list of 7 or 8 of his accomplishments. First, to predict the return of the comet named after him. Second, Astronomer Royal, Fellow and Secretary of the Royal Society, sponsor of Sir Isaac Newton's Principia. You'll notice I did mention all of those things in my talk. Then some stuff I didn't get to. Editor of Philosophical Transactions, civilian professor of geometry, I did mention that one, oceanographer, meteorologist, geophysicist, inventor, navigator, and famed for his researches in determining longitude. He laid the actuarial foundation of life assurance. And I didn't mention that, but yes, he was a well-rounded, I mean, he had his fingers in a lot of different scientific pies. So yeah, his legacy extends far beyond his comet. Let's see, I'm almost at the end here. Yeah, together with his geomagnetic surveys, you could say that Halley was one of the first modern geophysicists. And one of the spin-offs of his interest in magnetism is that he tried to scientifically date the stones at Stonehenge. I'm not sure how well he succeeded, but that is something he tried to do based on his estimates of changes in the Earth's magnetic field over time. And he designed and built a diving bell whose occupants breathed fresh air sent down from the surface in weighted barrels. And in one demonstration, Halley and 5 companions descended to 60 feet underneath the Thames, remaining there for an hour and a half. So he just did just a staggering array of stuff. And his comet, meanwhile, continues its sojourn. Last December, it reached the most distant point in its orbit, known as aphelion. At that moment, it would have been about 25 astronomical units away from us. That's 2.5 trillion miles beyond the orbit of Neptune. But rest assured, it will be back. And that's the end of my talk. So thanks very much.